Okay, I think I'm live now. Okay, if my audio is perfectly crystal clear, can people in the chat tell me if or if there's any issue with that, let me know so that I can see. Okay. A06 Satya Prakash says hello, hello Prakash. Please give me hint. For which problem, Satya? We have Anupam saying something. Please have a look at my solution for problem A. Let's see out A into. Okay, Anupam, you are actually missing an edge case here. The edge case is when b equals to 2, then you'll have x and y same. Just wait a little, I'll explain this per particular example in my stream. Okay, okay, cool, cool, cool. I see today's contest was a little harder than usual contest because as we can C got around 1100 submissions, which are usually around 2000, and in D we have 134 submissions. These are actually around 700, I would say. Okay. And people did really take time in C, and it was actually a little difficult than usual Codeforces C as well, I think. Yes, we can hear you. Monty says, okay, perfect, perfect. Okay, I'm just waiting for a few more people to join, and then I'll start. Okay. Okay, I'll just let you know about what Unacademy is doing actually. Okay, so this is just a second. Yeah, this is a little bit about me. I am a software developer at Adobe, and before this, I was working in DSHA as a member technical. On Codeforces, I am not a candid master right now, but yeah, I used to be candid master. Now I'm a expert myself. Apart from that, I'm 5-star on CodeChef, and I will be teaching competitive programming things related to that on Unacademy. These are the different things that you get when you get an academy subscription. You get access to live interactive classes, you get practice problems, and you get doubt support. Uh, these are the plans. I would say go for a 12-month plan because it is very efficient in terms of per month. Then a good thing that I have is that you can actually use my referral code, which is NBYT, and you'll get a straight 10% discount on the subscription. Then this is me. This is my handle on Unacademy. You can just go unacademy.com/noun1013 and find me there. Follow me, and you can watch all my classes there. I have some classes scheduled. I'll be telling that at the end of the stream. Okay. Okay, cool. So we have 13 people watching right now. Okay. Raghav says, Anupam, think about b equals to 1. Yes, Anupam, think about b equals to 1 and think about b equals to 2. Pranjal says you are from which college? I am from JIT. I graduated from JIT Sector 62 Noida last year. Okay. Okay, can people tell me how many problems they were able to solve? It's perfectly fine if you're not able to solve any problem today. That's okay because today's contest was not like the usual Codeforces round. It was a little difficult than that. Even A had a few edge cases and all today. So it's okay if you're starting with CP and you didn't solve anything. Okay. Pranjal says okay. A. Okay. What about B? How many people were able to solve B today? And C also. Is there anyone who was able to solve C today? I think many of you might not be very much like known about interactive problems, so that is something you'll get to learn today. Okay. So it says got B only. Okay, cool. Oh, what to do with time limits in Python? Ritvik, I don't really have much knowledge about that. I know that there are some issues with time limits in Python, but I'm not the very best person to tell you about this. Raghav says maybe. Okay, okay, perfect. Okay. So I'm guessing Okay, cool. Okay, I actually planned that I would tell A, B, C, and D, but looking at the submissions for D, I don't think it's a good idea to tell about C. Okay, cool. Okay, just a second. Okay, cool. Let's start now. So we will be doing A, B, and C, and if people say, I'll talk about D as well, but I don't think many people will be interested in that today. Okay, so let's start with A. So in problem A, Nastya has two positive integers, A and B. She defines that an integer is good if it is divisible by A into B. Okay, so let me just write everything. So we have two integers that are, one is A and one is B. Okay, cool. Then the integer is good if it is divisible by A cross B. Otherwise, the integer is nearly good if it is divisible by A. Okay, so to mark an integer as good, it needs to be divisible by A cross B. And to be nearly good, so we have nearly good. For an integer to be nearly good, it needs to be divisible by A. Right? Okay, cool. So, for example, A equals to 6, B equals to 4. The integers 24 and 72 are good. The integers 6, 6, 60 and 12 are nearly good. Okay. The integers 16, 7 are nearly good, nor nearly good. Are neither good nor nearly good. Okay. Find three different positive integers x, y, z. Okay. So, we need to find x, y and z such that exactly one of them is good and the other two are nearly good. And we need to make sure that x plus y equals to z. Okay, cool. So, okay, let's talk about the numbers divisible by a. So, the numbers divisible by a are actually going to be something like, let's take three variables. So, we have what? Okay, so let's say the numbers divisible by a are ma and the other number divisible by a is na. Cool. So, we have two numbers divisible by a and the third number should be divisible by a and b both. So, let's say we have o, a, b. This is the third number. Now we are given that x plus y should be equal to z. Now if you look at these three numbers, there's one thing that is very clear, that this number will be the largest number. Now there are ways in which we can make the other numbers as large, but for simplicity we can say that in most of the cases this number will be the largest number. So what we can do is we can say that this is z, this is y and this is z. Now from this we get that MA plus NA should be equal to OAB. Now what this tells us, so basically this is M plus N times A should be equal to OAB. This actually gives us M plus N should be equal to OB. I hope this is clear to everybody. Right, okay. So I think I lost my duster. Okay, cool. So let's just remove this. So now we know that M plus N is actually equals to OB. Now since we don't really care, like we do not have to optimize the solution, or the values don't have to be the minimum values or the maximum values, let's just assume that this O is 1. What this gives us is that M plus N is actually equal to B, right? Now let's assume that this M is also 1. Remember, we are not given that we need to find the minimum values or the maximum values, therefore we can assume anything. What this gives us is that 1 plus N is equal to B, which actually gives us that N is equal to B minus 1. So from this, we know that we fixed M equal to 1, N equals to B minus 1 and O equals to 1. So let's just see if we are able to make a solution from this. Now, we need to make this equation here. M is 1. So 1 into A is actually A. Then we get N as B minus 1. So we have b minus 1 into a, cool. And then the third value is OAB. Now O here is equals to 1. So we can say that this is actually equal to AB. Okay, so this is actually our answer. We can just print, so basically we are supposed to print all the three numbers, so we can just write A, the other number will be b minus 1 into A, and the last number will be equals to AB. Now there are a couple things that you need to notice. What happens when b equals to 1? So basically this should have been the solution, but there are a few things. So what happens when b equals to 1? If b equals to 1, a problem will occur. That is, if b equals to 1, first of all, this value will actually become 0, right? And we cannot make this value 0. Now, there are solutions for this also. So basically, instead of having O equals to 1, we could have taken it as a different number, and then we might have a solution for this. But the problem after that is that if b equals to 1, no matter what value we choose for x, sorry, this is x, no matter what value we choose for x, let's say ma is x, this value will always be divisible by 1. Therefore, there is no way we will ever be able to make a nearly good number. Every number that we make which is divisible by a will always be a good number. That is why for b equals to 1, there is no way we can find a solution. So if there is no way, we can just print no. Right. Now let's come on to b equals to 2. What happens when b equals to 2? So this actually becomes, so a remains a, b minus 1 actually becomes 2 minus 1, which is 1. So basically this also becomes a, and this remains ab only. Right. Now this should be right because b is 2 and this is equal to 2b, and a plus a is equals to 2b. But if you see in the problem, we are given that find 3 different positive integers. Now in order to actually make these values different, what we can do is we can actually have a corner case for this. Instead of having a here, we can write a plus 3a, and the last value, sorry, okay, yeah, so we can have 3a and the last value will be 4a, sorry, yeah, not 4a, actually like ab only. Now the reason why I'm doing this is because, sorry, this will be 4a. Yeah. Now the reason why I'm doing this is because we know that b is equals to 2. Therefore this value should be divisible by a and 2 both, and these two values should not be divisible by a. So therefore I cannot take this value as 2. Instead I took this as 3 because I know I cannot make this value even. If this is even, this will be divisible by 2, right? Therefore I took this as 3a and I made this as, so 1 plus 3 is equals to 4, therefore this becomes 4a. Since this is 4a, we know that this is divisible by 2 because this is 4 and 4 is divisible by 2, and it was already divisible by a. So basically all you had to do was, if value b equals to 1, then we have to write no. If b equals to 2, then our solution will be a, 3a and 4a. If b is anything other than 1 and 2, we just write a, b minus 1a and ab. Okay, I hope this is clear to everybody. Now one other thing that we need to notice that, okay, yeah, so basically a is 10 to the power 6, b is also 10 to the power 6. Therefore this value, the second value and the third value will actually go in the range of 10 to the power 12. Therefore instead of taking int, we actually need to take long here. I'll just briefly show my code to everybody so that they can see. So what I have here is I have scanned a and b in long since the numbers can be bigger. Then if b equals to 1, I just write no. If b equals to 2, I write yes, and I have the 3 numbers. So basically we have a, 3a and 4a. So I have a, 3a and 4a. Then if b is anything other than 1 and 2, I just write c out yes, and I have a, b minus 1 into a and a into b. Okay, I hope this is clear to everybody. It's okay if like you are a beginner and you are not able to solve this. It had a couple of corner cases which are okay if you miss them in the starting. You'll eventually, if you practice, you'll eventually get better at this, like thinking about the corner cases and everything. Okay, so let's move on to problem D now. I hope A is clear to everybody. If anybody still has any doubt, you can tell me, or you can just go back in the stream a little and watch my solution again. Okay, cool. Let's move on to problem B now. Okay, so the problem B is Nastya and a good array. Okay, let me just remove. Okay, I'll just keep this on the board only if anybody wants to read this. Okay, Nastya has received an array of n positive integers as a gift. So she calls such an array A good that for all I, 2I and okay, takes place Gcd of Ai comma Ai minus 1 comma Ai is equals to 1, where Gcd of UV is the greatest common divisor of integers U and V. Okay. We can perform the operations, select two different indices I and j and two integers x and y, so that minimum of Aij is equals to minimum of x and y. Okay, then change Ai to x and Aj to y. Okay, the girl asks you to make the array good using at most n operations. It can be proven that this is always possible. Okay, now there are a couple of things to notice in this problem. Okay, so basically, the first thing that they say us is that the GCD of A of I minus 1 and AI should be equals to 1. What this means is that every consecutive value, every consecutive pair in the array should have a GCD of 1. The next thing that they tell us is that minimum of, whenever we are making an operation, the minimum of AI comma AJ should be equal to minimum of X and Y. Now X and Y here are the values that we change AI and AJ with. Okay. And AI is actually changed to X and AJ is changed to Y. Okay, perfect. The girl asks you to make the array good using at most n operations. Okay. So, and we are given n operations. Okay. The very first thing that we get to know from these n operations is that for every integer in the array, for every index in the array, we are going to use one operation. This is the very basic thing that we can take out from this particular line, that we have in total n operations to do. Okay. Now let's look at this equation. So basically, we know that minimum of Ai comma Aj should be equals to minimum of x comma y. What they are actually trying to say is that the minimum value of out of Ai and Aj will remain the same. Now let's say Ai was minimum. Okay, if Ai was minimum, you can actually make either x as equals to Ai or y as equals to Ai. If x is equals to Ai, what that means is that because we are actually eventually going to change Ai with x and Aj with y, if we have x equals to Ai, then we are actually just changing Aj with y. But if we have y equals to Ai, then we are changing Aj with Ai and we are changing Ai with something else. So since using this operation actually makes it things very complicated, let's just stick with this operation only. If x is equals to Ai. So basically what we have now is we just need to select two values, any two indexes, and then change any one of those indexes to something bigger than the other index, right? Okay, we have Puneet and Himanshu saying something about the previous problem. We have Abhishek also saying. So I'll just complete this problem and then I'll come back to the queries, the three queries, and just briefly tell what is wrong with them. Okay, so let's talk about this first. Okay. Cool. So we have minimum of Ai comma Aj is equals to minimum of x and y. Okay, cool. And now we have already fixed that Ai is equals to x. Okay, cool. Now let's look at GCD of Ai. So basically we are supposed to make a sequence such that every consecutive pair has a GCD of 1. And if you actually ask me, the only sequence that we have for that is if we either have all the values as prime values, but that actually makes things very complex. So let's just stick to a very basic sequence, which is actually, let's say if the first value was x, then we can fix that the next value will be x plus 1. We can make the very next value as x plus 2, then x plus 3, and so on till x plus anything. So what this actually see, if you see, these two values have a GCD of 1, these two values have a GCD of 1, these two values have a GCD of 1, then the next two will also have a GCD of 1. So let's just aim to make a sequence which is actually strictly increasing by 1. Okay. Cool. Now in order to do that, we need to first make the very first value of our series as the minimum value. Because if we do not do that, let's say, so basically we have to make x plus 1, x plus 2, x plus 3, and so on. Okay, cool. Okay. Now, in order to do this, we know that we are actually going to be keeping the previous value as similar. So ai will always remain ai. So x will always remain ai. So if we take any index, we know that we're actually going to keep this index as same, and the very next value will be bigger than that, because the next value that we need to make is going to be x plus 3. Now, since we are doing this, we need to first bring the minimum value in the starting. Okay, so that every value that we get after this is actually greater. In order to do that, let's look at a couple of examples. So what we will have to do is, let's take the very first example. So we have 9, 6, 3, 11 and 15. So the very first query that we will do with this is, we'll actually see which index has the minimum value. So we saw that this 3 is the minimum value. What we will do is, we'll actually swap it with the third value. So this will become our ai, this will become our aj, and x will be, so we already know that x is ai, therefore this will become 3 only, and y will become 9. Okay, so the operation will actually be, so we'll write the indexes of this. So we'll have 3 as the third index, we'll have 1 as the first index, and then we'll have ai. So ai will, okay, so yeah, ai will become 9, because we actually need to make, x will become 9 because we are actually changing these values. So ai is supposed to become, yeah, so we'll make this as 9 and the other value will be 3. So basically it will switch the value at this index with 9 and the value at this index with 3. So what the next array will become is 3, 6, 9, 11 and 15. Now we have used one operation and we have fixed a very first index. Now we just need to make this sequence strictly increasing by 1. In order to do that, we'll just eventually have a for loop from I equals to 2 till the end. So the next thing that we're actually going to do is, we'll fix ai as this 3, we'll fix x as the value of this ai, and we will take y as this index, and aj will become 3 plus 1. So basically we'll have 1, 2. 1 is actually I, 2 is actually j, then the next value is the value that we want at ai. So the next value will become 3. So we'll have 3 here, that a of 1 should become 3, which it already is, and a of 2 should become 3 plus 1, which is actually 4, right? So the next thing, this will become now 3, 4, 9, 11 and 15, right? The next thing that we'll now do is, we can either select this or this index, or we can just keep the very first index as common for everybody, and we can just keep on iterating the j only. So the next iteration that we'll do is, we'll have I as 1, that I is again 1, we'll have j as 3, that we are now taking the third index. Then we'll have x. X is something that we are going to replace in place of ai. Ai is 3 and we want to keep it that way only, so x will become 3 only. Now aj is, now we need to choose y. Y needs to be strictly greater than 4 by 1, so that is 5. So basically we'll write 5 here. The next array will become 3, 4, 5, 11 and 15. And similarly, in the next iteration we'll change this 11 to 6, and in the next iteration we'll change this 15 to 7. And if you see this array, in this array, every consecutive pair has a GCD of 1. And that is exactly what we needed to do. Okay. So I hope the logic is clear to everybody. There are a couple of things that you need to understand in this, but I hope it is clear to everyone now. I'll just show the code and explain everything in the code so that it's easier for everybody. Okay. Okay, so what I'm actually doing here is, I'm scanning n, I'm just scanning the n, then I have taken the array. I've kept one based indexing for this particular question, because in the output we need one based indexing. Now in this for loop, I'm scanning the array and I'm actually finding the minimum value as well. I'm actually finding the index of the minimum value here. Now the reason I had this if and else is because I could have just used the else part, that I just have to take n queries and I could have printed every query. But if you look into the question, they've actually mentioned that I and j should not be equal. So if my minimum value is already 1, then I do not need to make the very first operation in which I actually change the minimum value to the first value. So if my I is already equals to index is already equals to 1, I only have to make n minus 1 operations for all the values after the minimum value. Otherwise, I'll have to make n operations. The first operation in these n being bringing the very minimum value in the starting, and then the rest of the n minus 1 operations. And then I just print. So this is the very first operation that I need to do for the minimum value, and then I just swap those values, and then I do for every next value after 1. So basically, for I equals to 2 till I less than equals to 1, I'm just putting out the operation. I'm swapping the value. I'm changing the values as and making it strictly increasing, and that is it. So it was an easy question, but yeah, it had a few things to like understand. So it's okay if you were not able to do this in the start. Okay, I hope this one's also clear to everybody. Okay, I'll just explain the things that we have in the chart. So Abhishek Ja says when A equals to 2, B equals to 4, can you solve it? Okay, so this is regarding the first problem actually. So when A is 4, A is 2 and B is 4. Okay, so the values will be A, B minus 1 into A and AB. So this is 2, this is actually 4 minus 1 is 3 into 2, this is 6, and this is actually equals to A. So if you see, this is only divisible by 2, the 6 is only divisible by 2, and this 8 is divisible by 2 and 4 both. So Abhishek, I think yours is done. Let's come on to Abhishek also says, what if in first question if A percentage B equals to 0? Let A equals to 6, B equals to 3, we can make two numbers only divisible by A. No, Abhishek, we can actually make. So let's say if A equals to 6 and B equals to 3, we can have what? So no, wait. You are saying when A equals to 6 and B equals to 3. Yes, you are right here. We cannot make that. Just a second. So if you are saying A is 6 and B is 3, values are A, B minus 1 into A and AB. So this will always be two numbers only divisible. Just a second. I think I myself am getting confused now because you choose one number is 6 and the other is. Rishabh says, "Can please repeat second question?" Rishabh, can you just quickly go back like 5 minutes in the stream and just look at the solution only so that because I don't think explaining it again will be beneficial to everybody. Just go back fast for 2 minutes and come back. Okay. Uh, first question. I am kind of thinking that Abhishek is saying right here, but there must be an obvious reason that it is not right. So just give me a minute. Let me see. Is there something written in problem A which actually says that this is not possible? Okay, we have A this. Okay. Okay. So, so for this we'll actually get 6, 12 and 18. Now all three numbers are divisible by 3. Hmm. Okay, let's just like give me some time. I'll have this in the back of my head. I'll keep on thinking while like having the stream on, and I'll just in the end I'll explain why this is not working. But like to be honest, right now I'm thinking like this should work. Okay. Other things are Puneet says, what if we print A, A, B, and A, B plus A? Huh, okay. Puneet, I'm not sure. Maybe this is right. Maybe there are some edge cases that might not be right for this one. So just look into some edge cases. If b equals to 2, what happens in those? If it is right, then obviously this will also pass. But I would say, like, don't go have z bigger than a into b. Himanshu says a cross b plus 1 and ab will be wrong. No, it won't be wrong. I'm pretty sure like there must be some cases in which this. No, sorry, you're saying ab plus a. Okay, so you're taking a times b plus 1 as z. Again, I think it is. Oh, it is same as the previous one only. So just see if this is right or wrong. There might be some couple of edge cases that you might be missing in this. Okay. Then Anupam says in A the answer is always right, right? No, Anupam, in A every answer is not. We like for B equals to 1 the answer is no. Okay, cool. David Dexter says बाकी lectures के videos complete क्यों नहीं है? Which lectures are you talking about? Can you tell me? I think like all are complete, I guess. Okay, so let's just okay and Abhishek, I'll just keep in mind your example and I'll see like what is the issue in this because I myself am thinking that this must be right. Puneet says only one edge case of b equals to 1. Yeah, then it's perfectly fine. If it is working a, b and a, b plus 1, then I guess a, b plus a, then I guess this is also a solution. Okay, so let's come on to problem C now. Can people tell me like how many people were able to solve A and B both in the contest and how many were able to solve C as well? Okay. Anutosh says A, B plus A. Yes, that is working, I guess. Since Puneet also said this and Himanshu also said this, I guess this is also working. Okay, let's move on to problem C now. Okay, cool. So the problem C is that okay, I'll just explain the problem. So Nastia has a hidden permutation P of length n consisting of any of integers from 1 to n. Okay, yes, for some reason want to figure out the permutation. To do that, you can give her an integer t, which is 1 or 2, two different indices I and j, and an integer x, and x lies from 1 to n minus 1. Now, there are two operations that we can do. If t equals to 1, we can have, okay, this operation, and if t, so let's just write, if t is 1, the operation that we can do is maximum of, minimum of, x comma, pi, comma, minimum of, x plus 1, comma, pj. And if t equals to 2, we have minimum of, maximum of, x comma pi, comma, minimum of, x plus 1, comma, pj. Sorry, this is maximum. Okay, cool. So these are the two operations that we can do, and the total operations that we can do are 3n by 2 plus 30 times. Okay. Rishabh says your output array is different from question. Yeah, in the I guess you're talking about problem B. In the problem, it is mentioned that we can have multiple outputs for that. Okay. So the way actually I got the hint for this problem was I actually looked at the number of queries that we have. So the queries are actually, if you just break this down, this actually becomes n plus floor of n by 2 plus 30. Okay, cool. Okay. So by this n, what I'm actually getting is, if I can bring any one number out of this permutations, maybe there is some way to find all the rest of the values in the permutation. And by this, I think like this is what my intuition told me when I read the problem and saw these queries. that this might be a way, these queries might be for finding out that particular one value. Okay, so okay, let's just remove the queries for now, and let's look at this. What this is, so basically this is minimum of, I'll write it a little bigger now, minimum of maximum of x comma pi comma max of x plus 1 comma pj. Okay, cool. Now let's see how many ways are there in which we can actually get the value of this complete thing as equals to 1. Because since I actually pointed out that we need to find one value, so that one value will either be 1 or n. That is the very easiest way we can do this equation. So let's just say that we wanted to find n equals to the index of the first value. Okay, now how to make this value 1? Now one thing is clear, that this x will always be 1 for that, because if we take this value greater than 1, this value becomes greater than 1, then what? If this value, okay, if this value actually becomes greater than 1, then this maximum will be 2 or 3 or something at least, and this will be 1 greater than that at least, because here we are using x plus 1, so this value will never become 1. Now in order to do that, this x must always be 1. If this is 1, this x plus 1 will always be 2, right? Okay, cool. So we have, okay, so we have x as 1, x plus 1 will become 2. Now let's see what happens when we place one time at pi and the other time when we place 1 at p2. Cool. So let's try to put pi as 1 here. If this pi is 1, so if this becomes 1, now this complete value will be 1 now. Cool. And the other value, let's look at the other value. So we have already used 1 from the permutation. This j will be anything greater than equal to 2. This is fixed. And we have to find the maximum value. So this value will be greater than or equal to 2. Now we had to find the minimum of this. Minimum of this will actually come as 1. So if we fix x as 1 and pi as 1, we are actually getting 1 out of this equation. Now let's see what happens when we fix pj as 1. If we fix pj as 1, let's see what happens. So okay, so this was pi, and let's rub this. So basically to get to 1, we had x as 1 and pi as 1. Now let's see what happens when we fix pj as 1. So if we fix pj as 1, now since this is 1, we know that pi will be anything greater than, so basically we'll have maximum of 1 comma anything greater than or equal to 2, because 1 is already used at pj. So this maximum will actually become greater than or equal to k. Let's come here. We know that pj is 1 and 2, we have x plus 1 as 2. So maximum of this will be 2. And minimum of something greater than or equal to 2 and 2 is actually 2. So we are getting 2 when x was 1 and pj was 1. Okay. Now let's see how many values do we have in the array. So in total we have n values in the array, right? And we know that by using one operation we can actually check for 2 indices. Let's say we had this as the array permutation. Let's say we took the very first 2 values. If the answer of these 2 values was either 1 or 2, there is a potential that either pi is 1 or pj is 1. So we can actually put this somewhere that it is possible that either this value is 1 or this value is 1. It is not entirely true that maybe any of these values will be 1, maybe none of them is 1, but there is a possibility that either this is 1 or this is 1. Similarly, now since we are done with these 2 values, there is no point of checking any of these values again. We can just move on to the next 2 values and again check if this operation is giving us 1 or 2. If this is giving us 1 or 2, then we can say that this must be there is a possibility that either one of these 2 is 1. Similarly, so what we are actually going to do is we'll actually iterate this complete array by pairs of 2 and check how many outputs did we get, either 1 or 2, and keep those indexes. So let's try to find how many maximum indexes we can get when the answer is either 1 or 2. Okay, so basically what we need to find out is that, okay, I'll just remove this as well, that this complete value should either be 1 or 2. Now in order to have 1, we know that this was 1 and pi was 1. If you say, and if you see, there is no other possible way to make 1, because if we have 1 here we get 2, if we have anything other than 1 here then we get something greater than 2. So there is no other way to have 1 here instead of, so the only way to have 1 of this final operation is that when pi is equals to 1. So that means there are multiple ways to get 2. Let's see how many ways do we have. So one way that we have is when when pj is equals to, so basically let's say that pi and pj are pairs. So basically one way is that when we have pj as 2 and pi is anything other than 2. Okay, but not equal to 1, right? Because if it is equal to 1 then we get 1. Okay. The other possible way is when we have pi equals to 2. If pi is equals to 2, then no matter what value we place at pj, the value of this equation will always be 2. Okay, so I hope you are getting this. Okay, so with this, what we can actually say is that, so basically what this tells us is that either pj is 2 or either pi is 2. So what this means is that, let's say this was a complete array. If 2 was somewhere on the even index, then it will have its odd index with this, and we'll have a query for these two indexes, because we are actually having queries in pairs. So we'll have a query for these two, then we'll have a query for this and this. When we'll have a query for this, we'll get that the answer of this is 2. Therefore, we can say that, now we cannot be sure, maybe this is 2, or maybe this was 2 or this was 2, because we can see that if this is 2, if pi is 2 or pj is 2, there is a possibility that any of these might be 1, right? So we cannot say which one out of these is 1 or 2, but we can say that either any of them is 1 or 2, right? So we have two indexes out of which we can say that the answer is 2, that there is a possibility of having 1. Similarly, let's say if we had 2 on the left side and right side was clear. So if we did a query on this, this will also result in 2. Since this will also result in 2, we can say that there is a possibility that this anything out of this was also 1. So if you see, and for 1 we already know that 1 had to be on the left side. So basically to have the answer as 1, we know that pi should be equal to 1 and pj should be anything other than 1. So if you actually see the maximum, so basically 2 can be either here or here. So this is giving us 2 values, either of which is 1. Then this is giving us 2 values, or maybe this. So basically we'll either have this condition or this condition. So basically there are 2 more indexes which have a possibility that either one of them is 1. And as you can see, we are actually running this in pairs. So if n is odd, one more value is left at the end which is not in pairing with anything. So let's just say that this can also be the answer. Okay, so plus 1. So if you see, in total we'll get 5 indexes which might have 1. Now we are sure that any one out of these 5 indexes will have 1. Apart from these indexes, every other index has something other than 1. Okay, so let's just see. Okay, what this tells us is that we actually have 5 indexes, and any one out of these 5 indexes is 1. Cool. Now let's see if there is any way we can actually see which value has 1. Okay, so for doing that, what we need to see is that, okay, so I'll just put this here. So basically we had 5 indexes and any one out of these was 1. Okay, I hope people are able to follow along. This is a little tricky, so you might have to go through the solution once again. Okay, so let's see how can we make sure that our index is 1. Now in order to do that, let's see what happens when we have pi as 1, and let's see what happens when pj is 1. this is something that we had already noticed. When pi was 1, we know that this complete value came 1. Okay, if pj is 1, we know that this complete value was coming as 2. So what we need to do is, let's just say that we are checking for this particular index. So let's say this is I. Let's take j as any one of these indexes. So let's take this as j only. What we will do is, we'll first have a query for ai and aj, and then we'll have a same query for aj and ai, and then check if the query for ai and aj gave us 1 and aj and ai gave us 2, then we can say that ai was 1. Are you getting this? Like, so basically we know that if pi was 1, then we'll get the complete answer of this equation as 1. If pj was 1, then the complete answer for this equation was 2. So in order to make sure that pi is 1, we need to see that the first query gives us 1 and the second query gives us 2. Now, and similarly other way also. What if the first query gave us 2 and the second query gave us 1? If this happened, we would have said that aj is actually ai here. Because if we just reverse these values, these are actually similar only. So if this is the condition, then we can say ai is 1. If this is the condition, then we can say aj is 1. Okay, let's look at the queries, the number of queries that we had to make to ensure which index was 1. So we saw that we first had to make n by 2 queries, right? N by 2, lower bound of n by 2, because if we had odd queries, let's say we had 5, we had 11 as n, then we only did 5 queries in pairs, and then the last index we just picked it up as a possible value. So we had in total n by 2 queries, right? So we had n by 2 queries, and with these n by 2 queries, we found out that there are 5 possible places where we can have 1. Now for every pair, we're actually doing 2 queries. If this pair gives us a pair of 1 and 2 as solution, then the first index was 1. If this gives us as a solution of 2, 1, then the second index was 1. So if you see, if there are 5 values, this pair will have 2 queries, this pair will have 2 queries, and then for the last value, we'll actually have to take any one of these values and just check it with them. So let's say for this value, we actually took the first value again. So if you see, for 5 values, we had to make at most 6 queries. So n by 2 plus 6 queries. By using n by 2 plus 6 queries, we were actually able to find out which out of these indexes, which out of the index of the complete permutation was 1. Okay. So I'll just write this. So by using n by 2 queries, n by 2 plus 5 queries, at most n by 2 plus 5 queries, we were able to find the position of 1. Now let's look at the very first query. How to use this one and find out the position of other values. So let's write it again. So we have maximum of minimum of x and pi, comma minimum of x plus 1 pj. Okay, I hope this is visible to everybody. Now, since this is minimum, now in order to make this x insignificant for this equation, we need to have x as large as possible. Because if you look at the very first query, second query, we actually made this x equals to 1. The reason for that was because we wanted this x to become insignificant for this max. And to do that, we had to choose the lowest value for x. Now here we have min. Since we have min here, we actually have to take the largest value x possible. And the largest value of x, if you look at the equation, is n minus 1. So we'll make this x as n minus 1. So this equation actually turns down to maximum of min. Okay, I'll just write it here only. So this x actually becomes n minus 1, and this x plus 1 actually becomes n. Okay, cool. Okay, now let's see what happens. Now we know that we actually have to find out the maximum value. Okay, just a second. I think I missed something. Yeah, sorry. Okay, there's something I did wrong. Okay, so we had x and x plus 1. Okay, cool. Okay, just a second. David X says, सर लेक्चर 10 7 hours का था, अब 1 hour 40 minutes का है, बाकी वीडियो कहाँ से access कर ले please? Actually there was some issue with the live only in that, and the live actually kept running after the round as well, after the stream as well, though there was no content after that. But so basically the live became for around like 7 7.5 hour, and that is why like I had to later on trim the video, and now it's around 1.5 hour only, and that is a complete video, so don't worry, you didn't miss out on anything. Okay, I have few more things. Okay, cool. Okay, okay, let's get back. So basically what I had said, that we need to make these values insignificant. Now in order to do that, we'll actually make this as n minus 1. So this becomes n minus 1, and this becomes n, right? I hope everybody is able to follow along. Just a second, there is something bugging here. Okay, okay, now we need to make these values as insignificant. Now we know that the position of 1. Let's see what happens when we know the when we put this position of 1 here and here. If we put the 1 here, let's say we kept 1 here. If we would have kept 1 here, then this value would have become 1. Okay, this value would have actually become, so basically we'll have to find minimum of n minus 1 or pi. So if this value is, let's say, 4 5 or something less than n minus 1, then we'll have these values, and the maximum of these will be 4 or 5 or whatever we choose. But if this is actually equals to n minus 1, or let's say n, so for n minus 1 also we'll have this value as n minus 1. But if we had this complete, so if we had pi as n, this value will become, make this n as n minus 1, because we had to choose minimum of n minus 1 and n, so that is n minus 1, and the maximum will become n minus 1. So for n, we will not be able to figure out if, so basically if we get n minus 1, there is a possibility that this pi was either n minus 1 or n. Let's see what happens when we fix this pi as 1. If you fix this pi as 1, you can see that this minimum actually converts to 1 only. So this becomes 1 because n minus 1 and 1 is 1. This becomes n comma pj. So if pj is 1, so it cannot be 1. If this is 2, this will become 2. If this is 3, this will become 3. If this is 4, this will become 4. If this is 5, this will become 5. And if this is n, this will become n. Right? So with this, what we can see is, if we actually fix x as n minus 1, pi as the index of 1, then whatever the output of this equation, because we have maximum of 1 and something here, so this maximum will always be this value. So the output of this first equation will always be the value at pj, right? And we already know the index of pi. So we already had a permutation, and let's say in this permutation, this was the position of 1. So what we'll do is we'll fix x as n minus 1. So let's say the query will be question mark, first type of query, then this is pi, this is pj, x will be n minus 1, right? X will be n minus 1, pi will be 1. So pi will be 1, index of 1. So that is 1, 2, 3, and 4. So basically index of 1. So I'm writing p1, which is actually index of 1, right? Let's just say p1 is index of 1. And here I'll have 1, 2, 3. I'll not take this index, and basically every index that is not having 1. Because whatever index I put here, I'll get the value of this index as the output of this query. And since we had to find n minus 1 more values, we'll consume n minus 1 more, sorry, so basically, sorry, this was 6. We'll consume n minus 1 more queries, right? Let's look at the total count of queries now. So we already had taken n by 2, floor of n by 2 plus 6 queries, and we took n minus 1 more queries. So this actually makes n plus lower bound of n by 2 plus 5 queries. And the target queries were n plus n by 2 plus 30. Now these are less than that, therefore we can obviously use this approach. So I hope this question was clear to everybody. There were many things to notice in this logic, and many things to assume and think. So basically that is something that will get with practice. There wasn't any specific approach that you would have applied for this question and you would have got the intuition. You had to go around many things and see like which query you can use for what purpose. So basically the first query was used when we got the position of 1 and we had to find all the other places. And the second query was used to find the index of the one of value 1. To find the value 1, we had n by 2 plus 6 queries. To find the value other values, we consumed n minus 1 queries. Okay, I hope this was clear to everybody. This was not an easy question, I would say, like not for a C, at least not for a C. And I had thought that I would discuss D as well with everybody. Okay, I think testing is not done, therefore it is complete. Why is that not showing C as complete? Okay, for those, I think nobody is able to see my submission as well in the standings because I was in the testing phase, so I don't think they are reflected here. Let me just see. Yeah, you won't be able to see my submission, so I'll just submit all my 3 submissions so that you all can see my submissions as well. So let me submit for C. Then let's come on to A and B also. I'll submit for A and B. Okay, I have to show the solution of C as well, explain the solution of C. I'll do that in a minute. So for problem, I think I copied. Okay, I think I have copied B. Then problem B is then let's come on to problem A and submit this for problem A. Okay. Okay, all the 3 got accepted. So you can go to the standings and look for my submissions. Okay. Okay, let me just explain the code of C for a minute. So if you still haven't got the solution, just rewind a little in the stream, start at the very starting of my submission of my logic, and just look for that like one or twice, because I can say that this is a little tricky question, so you'll have to like deep dive into everything that I said. So you can just like do that once and it will be easier for you then. But don't worry, like if you are not able to like solve this problem, this is a little harder for C. I would say this should have been somewhere in D. Okay, and D actually was actually easier than C, I would say. For some reason, like since many people were stuck at C, therefore they didn't like try to solve D. Otherwise, I'm sure D would have got more submissions than C if it was the other case. Okay, let's okay, I'll just show the code of C now. So the first thing that I was actually doing was so basically if this was the complete array, I was actually taking pairs, and in every pair, if either the value was 1 or 2, I was assuming that any of these index will have 1. So let's see, this is what I'm doing. So basically I have a question mark 2, so my query is question mark 2, that I'm using second type of query. Then I have I. Okay, I have I. The next thing is I plus 1, and I'm actually incrementing I from 1 till n, and I have an I plus plus. So basically this I will take the first index first, then it will take the third index, then it will take the fifth index, and so on. Okay, so I have 2I plus 1, and then I have x as 1. So that is exactly what we were doing. Now what these queries, so basically when I have n by 2 of these queries, so basically this loop will run n by 2 times. What this is going to do give me is, it is going to give me 4 values in this possible vector, because we'll have at most 2 pairs which actually give either 1 or 2. Now, if this value was odd, so let's say in this also we have 7, n is equals to 7 here. So we had one pair this, one pair this, we had one pair this. Now the last value is left unchecked. So we could just take a query for this particular index as well with any of these values. But what I did is I just assumed that this might also be 1, and I just pushed this into the vector. So now we have 5 values, at most 5 values. Okay. So we are done with the first n by 2 queries, and now we have a possible vector in which either one of these, any one of this index is 1. The next thing that I do is I actually run a loop in this index and do the same thing. I go pairwise. So basically now my query is question mark 2, then I have possible of I, which is actually the index in possible I. So I'm just writing. So let's say this is pos of I. Then the next query is, if you see, pos of I plus 1 question mark percentage possible size. So this is nothing but pos of I plus 1. And what this percentage possible size is, because when this I becomes equals to the size of this, so because I had 5 values, so when I get I as the last value, there is nothing in forward to this. So I'm just having a percentage with the size of this. So basically the next value will actually become the first value. So my queries are 2 pos I plus 1, and I is x for this is 1. Right, and this is exactly what I explained. So basically if you see, for every pair I'm actually doing 2 queries here. Right, one is 2 pos I plus 1 and 1, and the other is 2 pos I plus 1 pos I and 1. Right, and I'm actually scanning the values in value 1 and value 2. Now, as I had explained earlier, if my pair of answer is 1, 2, then I can say Pi is the answer. If my pair of answers is 2, 1, then I can say Pj is the answer. Now, Pi was pos I, and P of j here was pos of I plus 1. So, if my value 1 is equals to 1 and value 2 is equals to 2, I can say that my 1 is present at possible I. Else, if value of 1 is 2 and value of 2 is 1, then I can say my 1 is lying at possible of I plus 1. If I get my solution, I just break. I do not need to run any more queries. So the maximum queries, if you see, the size of this possible array was 5, and I'm actually having, for every pair, I'm having 2 queries. So at most queries that I can have are 6. So now n by 2 queries were in the previous for loop, 6 queries I have now. And now what I have is I have the position of 1. So I fix answer of 1 is 1, that this one is the index where I have 1, and this answer is the final array. Okay. Now I know the position of 1. Now I had to find all the other values. So I just run a loop from 1 to n, 1 till n, and I just make sure that my I is not equal to the index of I, because I already know that position. And now for every value, I'm actually running my first query, which is, so basically the query was, as you remember, the query was question mark 1, that I'm running the first query, then the index of 1, which is 1, and then I, which is my loop, and then n minus 1 as x. So I'll just explain what this is doing. So basically I had maximum of, minimum of, now x here is n minus 1, so I'll just have n minus 1, then I have pi is 1, so 1 as in the value of 1, so basically we'll have 1 here, then I have minimum of x plus 1 is n now, and I have I here. So this value, we know that minimum of this is 1, and minimum of this is always I, because even if I is n, this value will remain n only. So we can say that minimum of this is I. We also know that this I is always greater than 1. The value at this I is always greater than 1, because we have already used the index of 1. So this complete equation is actually equals to value of I. That is exactly what I'm doing. I'm just printing out this query and then scanning the value that I get from the interactor and marking that as answer of I equals to value. And after that, I just print the complete array. So in doing this query, in this for loop, if you see, I'm actually running it from I till less than equal to n. So I have n basically iterations, but I just skip one iteration when the value is 1. So in total, I have n minus 1 more iterations. So these are the final queries that I take, and the sum of this actually becomes down to be 3n by 2 floor of this plus 5, which is less than the required queries. So this is right. So I hope this is clear to everybody. There were a couple of things to grasp in this. So just, even if you're not able to understand that's okay. Just rewind back and start looking into the solution again. You'll definitely get this, but yeah, it will take some time for you to get. Okay, I only see 2 likes in this video for some reason. Why is that? The previous video got around 100 likes. So why are people not liking this video? Can people like the video so that I know that the solutions were good for you? Okay, Rishabh say, okay, Yashashvi says in question A, it is nowhere mentioned that if number is divisible by B, then it is not nearly good. Only condition is that it should be divisible by A and not by AB. And I would say, Yashashvi, you are actually right. Yes, Yashashvi, I think you are right here. Exactly. Mm, is that correct? Because then why answer for n equals to 1 is no when b equals to 1? The integer is good if it is divisible by a, the integer is nearly good if it is divisible by a. Yes, we can say that it is not mentioned for b. So I think your analogy is right, and that is why I think who asked? Abhishek asked. So that is why I think Abhishek, the solution for 6 and 3 also exists. David exercise lecture. Okay, I've already answered this one. Okay, cool. Okay, I hope the solutions are clear to everybody now. I think it will show green for C as well. I had planned the solution for D as well, but I don't see the point of doing D now since C got many less submissions and D doesn't have many solutions at all. So I'll just skip D. For anyone who is actually thinking about D, the hint is just you have to make a bamboo. So just try to remove all the, so just fix any value and take that particular diameter of that value and just try to fix every other value on that diameter, and that is how you'll get the solution for this. Okay, and E also doesn't have much things in it. It is merely an implementation, so you can also try this one also. I guess the reason why there are no solutions for D and E is because C got very less submissions and C was actually tricky, therefore people didn't get much time to solve D and E. Like I myself was able to solve ABC only, but after that I did D and E. Okay, okay, let me see if we have more likes. Okay, we have 25 likes now. Perfect, perfect. Still, if you haven't liked, just like the video or let me know in the chat why you didn't like the video. Okay, there are a few things that I need to discuss. So I'll have a special class tomorrow on Unacademy, and the class will actually be regarding 2 pointers. So I'll have a class for 2 pointers. So I'll just show you where. So all you have to do is just go to unacademy.com/Naman Bansal. Okay, I wrote my name wrong. Naman Bansal 013. And if you go, you'll actually see the dashboard of my videos. So I only have one class right now. It is an hour class, and it is introduction to 2 pointers. I did around 12 days back. Sorry, 20 days back. So this is a very introductory video to 2 pointers. I explained I think 3 questions I explained, and I just explained why 2 pointers are used in problems. Okay, so if you haven't attended this class and you are not very good with 2 pointers, just attend this class. It is just a 1 hour class, so you can even, okay, I'll just close this. You can even just see the video in 2x and see what all things I did. What I'm going to do is I'm having a stream of around 2 hours tomorrow at 12 p.m. So basically the stream will be from 12 to 2, and what I'm going to do in these 2 hours, I'll just show you what I'll do. So I'll let me open LeetCode. Okay, I need to sign in. Just a second. Also, if anyone still has any doubt in ABC, they can write in the chat. I'll just explain it. And in the meanwhile, I'll show what I'll be doing in the tomorrow's class. Okay, so I will just go to 2 pointers in LeetCode. I'll sort them around on the basis of difficulty, and I see there are around 20 problems, easy problems on 2 pointers. So what I'm going to do is I'm actually going to solve all these 20 problems in those 2 hours. So it will be a very fast-paced class since these are very easy problems, I would say. So I'll just read the problem, explain what we need to do, write the complete code in front of you, and just, yeah, so like that is it that I'll have in the class. So I'll be solving around 20 problems in these 2 hours. Hopefully I'll be able to solve all the 20 problems in the 2 hours. If not, we'll see, either stretch the class or we'll have another class. But yeah, that is the whole idea of the class. So make sure that you attend my class, and to do that you just have to go to unacademy.com/namanbansal013. I'll even write that. So it is una, sorry unacademy.com/namanbansal013. So anyone on academy.com/, yeah, okay. So anyone who wants to attend this class, they can come there at 12 p.m. I'll be live there, and I'll be solving all these 20 problems. After that, we'll have another class in which we'll be solving medium problems as well, and then we'll have a class for hard problems as well. So make sure that you attend this class, because if you attend all my easy problems, then only you'll be able to do medium and hard. And yeah, it will be a very fast-paced class. So even if you know all the things, you can just come, you can just sit back and relax and just look at the solutions, like how I'm thinking and explaining everything, so that you know like why things are done and how things are done. Okay, so that is it about this. I think I'm missing something. I actually had two things to tell in the end, but I don't remember them now. Okay, cool. So I don't see people asking any more problems for ABC. I think people are able to understand. Even if you're not able to understand any of the problems, just go back in the class and see like what are the things that I did. Okay, so I think that's my cue. This is, sir, other than Codeforces, which platform I choose? I would say just stick to one or two platforms. Don't go roaming around on another platform, because then it becomes very difficult. So I would say, okay, so basically I have always been into Codeforces only. CodeChef, I haven't done much. I have given some contests, but yeah, if the other platform you're looking for, and only for contests, if you're looking, do go for CodeChef. Give long, obviously long, because long challenges are very good. Yeah, the other thing was actually related to CodeChef only. So long challenge has started. Okay, I'll just open up long dev 3. So if, as you can see, there are what, 8 problems right now. Maybe they will, I am pretty sure they'll add 2 more problems. Yeah, remaining 2 problems will be added soon. Okay, so I'll try to, just start, this contest started today only, so just make sure that you also give this contest, because long challenges are actually very helpful. I myself got to know about all the topics like 2 pointers, binary search, every topic that I know, I discovered them through problems from CodeChef only. So just give every long, not every long at least, but yeah, do give some of the longs, because in the starting it is very helpful. The problems in long do take time, but they are very helpful. So yeah, so right after 10 days, when the contest ends, so I think it ends around 3:30 in the evening. So right, the second the contest ends, I'll yeah, 3:30 only, I'll start a stream of around 3 hours, I would say 3 or 4 hours maybe, or we'll split the stream into 2 parts, and I'll be solving all the problems of this dev 3. Okay, so make sure you solve all the problems. You try to solve all the problems, so that while I'm solving them, you just have an idea of what the problem is, or you're able to follow along. Okay. So can you do CSS graph problem set? Abhishek, graph is something that I'll cover in the very end. I think there are many other topics like DP that I need to cover first. So the way I'm doing for lead code for 2 pointers, I'll be doing the same for DP as well someday. So let's just wait for greedy DP, binary search, and all those other topics, and then we'll eventually come to graph as well. Okay. Okay, I think that's the end of the stream. It was fun doing all the 3 problems. The problems were really fun today. So just make sure, even if you're not able to solve them in the context, you just upsolve all these problems. And even try D as well. It isn't much in D. Okay, so with this, I'm going to end the stream now.